Hi everyone. In this particular review video, we're going to look at the composition of our atmosphere. The word composition means what is our atmosphere made of? We tend to think of our atmosphere as being predominantly gases. And the main gas that we see in our atmosphere is actually nitrogen. Most students and most people in general think that we breathe in mostly oxygen because that's what our body uses. But in reality, if you look at the pie chart over here, you can see the majority of our atmosphere is considered to be nitrogen molecules at 78%. Now, 21% of our atmosphere is going to be oxygen molecules, and 1% is everything else. That 1% may be things like water vapor or carbon dioxide or hydrogen, but all of those together only equal about 1% of the atmosphere. Sometimes we can get things in our atmosphere that aren't actually gases. So during a dust storm or above a desert, we may get things like dust or sand that's able to be suspended by the air and is picked up, and it's actually a solid particle within that atmosphere. The ocean will put off salt at times. During the spring, we get a lot of pollen and pollen allergies because plants are putting that pollen off. And things like volcanic ash can get put into the atmosphere. And once it's there and suspended, it's considered to be a part of the atmosphere until it comes out of that air. And we can also get things like actual liquids. Clouds are water droplets, liquid water droplets that are being suspended in the air. So that's what a healthy atmosphere would look like. Unfortunately, we have things in our society, and even naturally, they get put up into the atmosphere that are considered a pollutant. A pollutant up here, if you read, is any substance that is harmful to the environment. Now, this can be a substance that's not supposed to be in the atmosphere, and it could also be a substance that's naturally found in the atmosphere, but it may be found in too high of an amount within the atmosphere. So the six main pollutants that we have in our atmosphere that either shouldn't be there or we have increasing amounts of are things like nitrogen dioxide and sulfur dioxide. And both of those can come from burning fossil fuels. And that is things like gasoline or natural gas or petroleum. When you burn that, it puts off something called fossil fuel emissions. And those fossil fuel emissions, when given off, go into the atmosphere, and we get a lot of nitrogen and sulfur dioxide. The reason why those are so bad is those are the two main ingredients that give us what we call acid rain. So when those two compounds mix and dissolve into water, which we know is the universal solvent, when it mixes with that water in the clouds or the water vapor in the atmosphere, it produces something called acid rain. Some more pollutants that we have in our atmosphere are things like carbon monoxide, which is produced by exhaust, once again, fossil fuel emissions, burning that fossil fuel through combustion. Ozone, which we tend to think of as good because ozone protects us from harmful UV radiation when it's up in the stratosphere. But when we have ozone being put off by by exhaust, at a lower level, then that actually becomes something that is bad. So ozone can be good or bad depending upon its location. If it's up in the ozone and being used to block out that harmful UV radiation, it's good. But if we have that ozone at a lower level, it's extremely reactive and it actually is very harmful to us. Another pollutant is lead from, once again, processing of gasoline and other metals. And finally, particulate matter. Particulate matter is any microscopic small solid that can be suspended in the air, like soot when we burn our wood in our fireplaces, or ash from volcanic debris, or even the pollen or mold that can be given off into the atmosphere by living organisms. Smog is one of those things that can occur when we are putting too many pollutants up into the atmosphere. Smog, if you look at this picture, is something that makes visibility very difficult. And it occurs when the sunlight reacts with those nitrogen and carbon compounds that we place into the atmosphere. So the air quality index is something that we use to actually measure the air pollutants that we're putting into the air. These air pollutants that we are measuring are the ground level ozone, the particulate matter, the carbon monoxide, sulfur dioxide, and nitrogen dioxide. And we actually looked at the World Air Quality Index in class to look at which regions had good air quality, which we looked for which regions had that green tag, all the way down to which regions had that hazardous tag, okay, that almost maroon color on their map. And we said that actually US had a lot of good reading or good atmospheric readings. And one of the reasons for that is we have passed legislation known as the Clean Air Act, which makes companies and factories and even the car manufacturers watch how many fossil fuel emissions are being put up. So it's something that is kind of monitoring those fossil fuel emissions, which is why the United States tends to have a lot of good air quality. Now, we did have areas that were at the moderate or unhealthy level, but we also talked about why that might be. But the Clean Air Act is legislation that was passed to try and keep our air quality at a healthy level. Some of the other ways to reduce air pollution, or that the Clean Air Act helps to reduce air pollution, is the fact that a lot of companies or factories have been asked to put filters or scrubbers onto their plants, onto their smokestacks. And what those filters or those scrubbers will do is will actually filter out a lot of that solid particulate matter, that ash that may be given off when we're burning fossil fuels. And they've been asked to use low sulfur coal to reduce that sulfur dioxide that is put off when we burn fossil fuels. Another thing that we do is we reduce auto emissions by watching or checking the vehicles for how much fossil fuel emissions are being put off. So there's ways to reduce that air pollution that's being put up so our air quality stays at that healthy level. Now, if we do tend to get sulfur and nitrogen dioxides up there in the air, we end up with something called acid rain. Acid rain is actually normal. So we normally have nitrogen and sulfur compounds up there in the air. And so on a normal basis, the rainfall that usually falls is going to be about a 5.6 to a 7. So it tends to be on the acidic side. But once the rainfall that pH gets below 5.6, that is considered acid rain. So anything below a 5.6 is considered acid rain, and that can corrode structures. That means break them down. It can harm forest and living organisms, which is why we're looking at our living bean plants and how the acid rain is affecting those. It can change the pH of our water sources, where we know we have a lot of living organisms living within those ecosystems. And we see a lot of the acid rain happening in regions where we have a lot of coal being burnt and where we have a lot of exhaust from those fossil fuel emissions, from that fossil fuel being burned. So the acid rain tends to be seen in those areas where we have a high population with that exhaust being given off. And here are some pictures of the effects of acid rain. Now, one of the other things that we talked about was some of those pollutants that we are putting up, like carbon dioxide and methane and things like that, are considered greenhouse gases. Those gases are good in natural levels because they will actually trap heat and radiate them back towards Earth to keep our Earth warm. If we didn't have that, our Earth's surface would actually be much colder than we are experiencing right now. And so life as we know it would not be at the comfortable temperature where we like it, that Goldilocks effect, not too hot, not too cold, just right. And so you can see here we have the solar radiation come in. Some of it leaves to space, which is what we want, but some of it gets trapped by those greenhouse gases and radiated back to Earth. The problem is when these greenhouse gases, water vapor, carbon dioxide, methane, nitrous oxide, and ozone, when they get to too high of a level, they will actually trap too much heat, and we can begin to see a warming effect. And that's called the enhanced greenhouse effect. And oftentimes we say that is kind of a result of human impact because so much of it comes from combustion, that burning of fossil fuels. Deforestation, cutting down the trees that take out the carbon dioxide from the atmosphere. Another thing that we have a human impact is CFCs. Those are chlorofluorocarbons. And one of the things those do is those come from aerosol cans and coolants, and those go up into the atmosphere and they actually break down our healthy ozone layer. So we tend to have legislation on how many CFCs we're allowed to put up because we want that good, healthy ozone up in the atmosphere. And so you can see here's the natural greenhouse effect, and here is the enhanced greenhouse effect. So pollutants in our atmosphere can change naturally, okay, and they can change unnaturally. And so we tend to say the enhanced greenhouse effect typically a human enhanced greenhouse effect because